Welcome back. In my previous video, I have seen what is the system of linear differential equation. I have seen system of linear differential equation means actually the homogeneous equation. And I have solved the solution of system of linear differential equation by matrix method. In my previous video, I have seen how the pure part and applied part are beautifully related. Today I will discuss just some more example of system of linear equation, but at first I will highly recommend you, if you don't see my previous video, at first see my previous video. First question, ddt of xt yt equal to the matrix xt plus 3yt xt minus yt. Here, how look like the solution space? Which type of vector the solution space is spanned by? Here, this solution space generated one matrix which is 2 cross 2 matrix 1 3 1 minus 1. Obviously, eigenvalue of this matrix is plus 2 and minus 2. Just calculate oneself. And with respect to eigenvalue plus 2, the eigenvector would be 3 1. And with respect to the eigenvalue minus 2, the eigenvector would be 1 and minus 1. So, the solution would be such type. Here the solution u equal to c1. v1 means here 3 1. E to the power lambda 1, here lambda 1 is 2t plus c2, here the eigenvector is 1 minus 1, e to the power minus 2t, lambda 2 means minus 2. This is the solution of this matrix. Now I will see how look like the solution space. Since ut equal to xt comma yt, at first consider c2 equal to 0 and c1 equal to 1. That imply x3 equal to 3 e to the power 2t and yt equal to e to the power 2t. And this imply x equal to 3y. That means when c2 equal to 0 and c1 equal to 1, then this line would be such type x equal to 3y. Y equal to 1/3 x. Therefore, the equation of this line would be such type. This is x, this is y. And when c1 equal to 0 and c2 equal to 1, then xt imply e to the power minus 2t and yt imply minus e to the power 2t. That imply xt plus yt equal to 0. xt plus yt equal to 0 means this line, and here for x equal to 3y, since e to the power 2t, that means as t goes to infinity, e to the power 2t always goes to infinity. So for x equal to 3y, the solution would be such type. But when xt plus yt equal to 0, solution would be such type, then the solution is e to the power minus 2t. That means the solution always goes to 0. Therefore, for this, the solution would be such type. And other non-trivial solution would be when c1, c2 is not equal to 0, then the solution would be such type. I hope my all viewers have understood how look like the solution space, how look like the solution space spanned by which type of vector? Okay, our next example. Next I will see our second solution. ddt of xt yt equal to beta yt minus beta xt, and this solution always generate one matrix A equal to 0 beta and minus beta 0, and eigenvalue of this matrix would be plus minus I beta. Then with respect to plus I beta is eigenvalue, the associated eigenvector would be, just solve it, this would be v2 equal to I beta 1. So consider v1 equal to 1, then the vector would be 1i. Therefore the solution for this eigenvalue would be such type: xt equal to c1 with this eigenvector 1 comma I e to the power I beta, and e to the power I beta means, since here I have considered only eigenvalue I beta, so here not included c1, here would be xt equal to the vector 1i e to the power I beta, and e to the power I beta means obviously cos beta t plus I sin beta t 1i. This imply cos beta t minus sin beta t plus I times sin beta t cos beta t, and since these two vectors are linearly independent vector, so we can write xt is generated by these two vectors c1 cos beta t minus sin beta t plus c2 sin beta t cos beta t, and this is actually not line equation of line. We all of us know this is actually the all circle which passing through origin, this type, this type, this type. This is actually the picture of this solution with respect to the eigenvalue plus I beta, and with respect to the eigenvalue minus I beta, the solution would be different type. And what is the direction? This is depends on the value of beta, and the value of the rotation depends on different value of beta. For this, consider beta equal to 1. When beta equal to 1, for easy calculation, consider c1 equal to 1 and c2 equal to 0. When c1 equal to 1 and c2 equal to 0, then xt equal to cos t and yt equal to minus sin t. And at the point t equal to 0, this goes to 1, 0, which is actually x-axis. And if we consider t equal to pi by 2, then this goes to 0 minus 1. Therefore, the rotation would be, this is x-axis, here 0 minus 1, rotation would be such type. For here, the rotation would be such type. I hope my all viewers have understood. For the eigenvalue I beta, here I have got two different linearly independent eigenvector, and for this eigenvector I have got the solution space. How look like the solution space of this system of second order differential equation? Oh, we don't need to use the second eigenvalue to find the solution. By first eigenvalue we can get the solution space of this second order differential equation. Our next example, similar type of example. Now if we consider this type of differential equation which constructed a matrix A equal to alpha beta minus beta alpha, then the eigenvalue would be such type alpha plus I beta, and solution of the differential equation would be c1 e to the power alpha t cos beta t minus sin beta t plus c2 e to the power alpha t sin beta t cos beta t. Obviously, here the solution is when C1 equal to 1 and C2 equal to 0, then the solution would be e to the power alpha t cos beta t e to the power alpha t minus sin beta t. This is equation of spiral equation, but this part, how look like the spiral? This is goes to origin or array to origin. This is depends on value of the alpha. This is the spiral. If alpha goes to 0, then direction would be such type. Also, this is with the spiral. If alpha goes to 0, this is goes to 0. But if alpha goes to infinity, then the spiral would be such type. The direction of the spiral would be such type, or direction would, or so spiral would be such type. That means there exists 4 possible spiral for this solution of differential equation. I hope my all viewers have understood this type of question easily. Okay? Well. Our next example, x1 dash equal to 3x1 minus 13x2 and x2 dash equal to 5x1 plus x2 with initial condition x1 0 equal to 3 and x2 0 equal to minus 10. And from this equation we can generate one matrix 3 minus 13 5 1. And here initial condition is 3 and minus 0. At first find the eigenvalue. Eigenvalue would be 2 plus minus 8i. And with respect to eigenvalue 2 plus 8i, the eigenvector is, with respect to the eigenvalue 2 plus 8i, the eigenvector would be such type x1 equal to 1 over 5 1 plus 8i x2. Consider x2 equal to 1, then the eigenvector would be 1 over 5 1 plus 8i. Consider x2 equal to 1. Therefore, this is the eigenvector with respect to the eigenvalue 2 plus 8i. Therefore, the solution would be such type x1t equal to e to the power 2 plus 8i times 1 plus 8i and 5. This is the eigenvector. Here I have considered one eigenvector 2 plus 8i. So, we cannot take here C1. So, with respect to the eigenvalue 2 plus 8i, the solution would be x1t equal to e to the power 2 plus 8it. Here the eigenvector, I have multiplied here 5. 1 plus 8i times the eigenvector 5. And this means obviously e to the power 2t and e to the power 8it means cos 8t plus I sin 8t, and here the eigenvector 1 plus 8i 5. I hope my all viewers have understood the geometry. Here I have not taken C1 because I have considered only one eigenvector. Eigenvalue 2 plus 8i. In other case, I have considered two eigenvector equally. But here I have considered only one eigenvector because with this eigenvector we have seen few minutes ago, when the complex root, I will always get two linearly independent eigenvector with respect to this eigenvalue. So I have taken here only one eigenvector. Taken here only this eigenvalue. I hope my all viewers have understood this concept, because few minutes ago I have told elaborately why I have taken here only one eigenvector, one eigenvalue when there exists complex root. Then the solution would be such type. Just break it. This is e to the power 2t and e to the power 8it means cos 8t plus I sin t. Here the eigenvector 1 plus 8i 5. Now calculate it oneself. Separate real part and imaginary part. This would be e to the power 2t cos 8t minus 8 sin 8t 5 cos 8t plus I e to the power 2t 8 cos 8t plus sin 8t and 5 sin 8t. And here given the initial condition, since these two vector is linearly independent vector, so we can write these two vector as c1 e to the power 2t cos 8t minus 8 sin 8t 5 cos 8t plus c2 e to the power 2t 8 cos 8t plus sin 8t 5 cos 8t. And since here given the initial condition, here extra condition is here given the initial condition. Since here given the initial condition, at the point 0 the value is 3 minus 0. So always we can evaluate the value of c1 and c2. Just put the value x0 equal to 3 minus 10. After putting the value of c1 equal to minus 2 and value of c2 equal to 5 over 8. Just put the value of c1, c2 here. Then the solution would be such type of solution. And after calculating, I will get these two solution x1t equal to e to the power 2t 3 cos 8t plus 133 over 8 sin 8t, and x2t would be e to the power 2t minus 10 cos 8t plus 25 over 8 sin 8t. Since here given the initial condition, so I have got one fixed solution. Okay, I hope my all viewers have understood. Here the solution always be fixed. In previous example, always c1 c2 be arbitrary, but here I have got the value of c1 c2. So the solution always would be fixed. Next question. With respect to the eigenvalue 2 plus 8i, I have got two linearly independent eigenvector x1 to t and x2 t. So for other eigenvector, we need not have to check the eigenvector. Okay? Oh well. Our next example is different type. X dash equal to lambda x plus y and y dash equal to lambda y. These two solution obviously generate this matrix lambda 1 0 lambda. Here y dash equal to lambda y. I will solve this question in different way. From previous method. Here given y dash equal to lambda y, that imply obviously y2 equal to c2 e to the power lambda t. Now another equation x dash equal to lambda x plus y. Just put the value here. Then this imply x dash equal to lambda x plus c2 e to the power lambda t. Okay. That imply x dash minus lambda x equal to c2 e to the power lambda t. That imply ddt of x e to the power minus lambda t equal to c2. Now integrating both sides, then this would be d of x e to the power minus lambda t equal to integration c2 dt, and after integrating this imply x e to the power minus lambda t c2t plus c1. That imply xt equal to e to the power lambda t times C2t plus C1, and the solution would be such type xt equal to C1 e to the power lambda t 1 0 plus C2 e to the power lambda t t1. The solution would be such type where capital XT means XT YT, here XT and here YT. Now my all viewers have understood how look like the solution of differential equation and how look like the picture. Just at first think oneself. Then in my next video I will discuss how look like the picture actually. Okay? Well, I will stop here. In my next video I will discuss this type of question is again, because this type is actually applied part, but this is actually use of pure part. Those students who will study in future for applied part, this type of topic actually very important. But here interesting, all applied part actually depends on pure part. See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.